Lecture notes for Chapter 21, Section 2. In Section 2, we take a look at chemical equations and balancing equations. Lavoisier, in his experiment with mercury oxide, saw that the reaction could be written as such. We have mercury oxide here in a solid state. Remember, S for solid. In the presence of heat, that means he had a little Bunsen burner with some heat, and it produced liquid mercury, the silvery liquid, plus oxygen gas. Notice that the number of mercury, I'll erase some of this. Notice that the number of mercury atoms is the same on both sides of the equation, but that the number of oxygen atoms is not the same. And hence, here's where we get into balancing equations. One oxygen atom appears on the reactant side, that would be the left side of the equation, and two appear on the product side. According to the law of conservation mass, one oxygen atom cannot just become two, nor can you simply add the subscript to and write HgO2 instead of HgO. The formulas in a chemical equation must accurately represent the compound that react. So, fixing this equation requires a process called balancing. Balancing process involves changing coefficients. Coefficients are numbers that come before the actual compounds in a reaction to achieve a balanced chemical equation, which has the same number of atoms of each element on both sides of the equation. Finding out which coefficients to use can often be a trial and error process, and when we get into doing some of the exercises and balancing equations, I suggest you use a pencil because you're going to be erasing and through a process of trial and error trying to figure out what numbers work. In the equation for Lavoisier's experiment, the number of mercury atoms is balanced, but one oxygen atom is on the left, the reactant side, and two are on the right. If you put a coefficient of 2 before the mercury oxide, HgO, on the left, the oxygen atoms will be balanced, but now the mercury atoms become unbalanced. To balance the equation, also put a 2 in front of the mercury on the right. The equation is now balanced. Go back and show you that. All right, what we have here is a coefficient of 2. This is a coefficient. And what this means is that we have 2 mercury parts in this compound and 2 oxygen parts. Again, becomes a math problem. It'd be like multiplying 2 times everything that's inside of these parentheses. If we have 2 of everything on the left side, we also have to have 2 on the right side. This coefficient 2 means that we have 2 mercury parts, and this O2 means that we have, because of the subscript 2, we have 2 oxygen parts on that side. So to balance the equation, we look and we see we have 2 here, reactants, and 2 on the products for the mercury. In the oxygen, we have 2 parts, and over here we have 2 parts on the product side. So the chemical equation is now balanced. Magnesium burns with such a brilliant white light that it is often used in emergency flares. Burning leaves a white powder called magnesium oxide. To write a balanced chemical equation for this and most other reactions, follow these 4 steps. You get these 4 steps down, so you should have no trouble balancing chemical equations, but I'll give you plenty of practice over the course of the next couple weeks. Step 1, write a chemical equation for the reaction using formulas and symbols. In this case, we have magnesium, a solid, combines with oxygen, a gas, to produce magnesium oxide, a solid. Okay, I can tell you right now this equation isn't balanced. The magnesium's balanced. You can see they have one part here and one part here, but the oxygen isn't balanced. There's two parts here and only one part on this side. So step 2 says count the atoms and reactants and products. Do a little cleanup here. As I said, we have 1 magnesium plus 2 oxygen, and again, the book editors screwed up. That shouldn't be, that's mercury. This should be MgO, and this doesn't exist. I'll tell you these guys if I ever catch them. So we have 1 magnesium on this side and 1 magnesium on this side, 2 oxygen on this side, and 1 on this side. So next step, choose coefficients that balance the equation. And again, it can oftentimes be a trial and error process. So 1 magnesium on this side and 2 oxygen. So to get the oxygen, the only thing we can do, you never touch these subscripts. All right? The only thing we can do is to add a coefficient of 2. Oops, excuse me. Add a coefficient of 2. And we now have 2 oxygen on the right side. But it throws our magnesium off. We now have 2 magnesium. So to balance, we need to put a 2 in front of the magnesium. And step 4 is to recheck the numbers of each atoms on each side of the equation and adjust coefficients again if necessary. And if you look at it at this point, 2 magnesium, again, remember the coefficient, 2 magnesium here, 2 magnesium here, 2 oxygen here, and 2 oxygen here, because adding that coefficient of 2 is like multiplying everything within the parentheses by 2. So we are balanced. And that's the end of the section 2 lecture. Question number 1 says, in a chemical formula, how is the number of atoms of an element indicated? And we just went through that. In a chemical formula, subscripts are used with symbols for elements to indicate the number of atoms. Question 2, what does it mean for a chemical equation to be balanced? And the answer, the choices. Compounds exist in the same amounts both before and after reaction, or coefficients are the same for the reactants and products. Answer A is the correct choice. There are the same number of atoms of each element on both sides of the chemical reaction, or the rate of formation of products is equal to the rate of formation of reactants. And I misspoke. The correct answer is C. Balancing an equation does not change what happens in the reaction. As long as you start with the same amount of reactants on the left side, and end up with the same amount of products on the right side. Question 3 asks, what is the correct balance equation for the reaction of magnesium and oxygen? In this case, we went through this problem. This problem, if we look at number 1, we have 1 magnesium plus 1 oxygen. This is not the way to write that. Oxygen is diatomic, which means there has to be 2 parts. So we can throw out this one. It doesn't have the right reactants. Magnesium plus oxygen yields magnesium oxide. Again, they haven't accounted for the fact that there's 2 oxygen on the product side, so this choice can be taken out. Choice number C, letter C, magnesium isn't diatomic. It doesn't exist as 2 parts, so this choice is wrong. We can look at it right from the start. Let's just check letter D, which is supposedly the right answer. We have 2 magnesium parts. We have 2 magnesium parts, 2 oxygen parts, 2 oxygen parts. And just one more time, by applying that coefficient of 2 means that everything to the right of the coefficient is multiplied by 2. So 2 magnesium, 2 oxygen. Letter D is the correct choice. Okay, and that concludes the lecture for section 2.